as I mentioned in the messages, we'll be meeting twice a week, Monday and Wednesday. I know that the CUNY, says it will be Wednesday alone, but I didn't feel very comfortable doing that. I wanted to, I mean, you may have questions when you're learning from the material posted on the Blackboard. That's how you're learning everything. But, not everybody can just understand by watching the video. You have questions. So I felt uncomfortable just meeting once. So that's why I volunteered to meet twice instead. So if the Monday meeting is not convenient for you, you don't have to attend it. It's not required that you attend. So if you are comfortable with the material that you learned from the video and there is no question and you don't have the time, you have something else, that's okay. You don't have to attend. And also there is office hours in the evening, 3 o'clock afternoon. And you can join the office hours to ask your question. But we'll be doing more in the class meeting, not just answering questions. I'll be posting some more problems to solve. And by working on those problems together, you learn better, those things. I tried that method over the summer, having the students watch the video for the learning part and then have discussion in the class meeting with problem solving sessions and all that. It worked better. And so that's why I decided to do that. And one meeting is not enough. And that's why I'm offering 2 meetings. So if you can attend the Monday meeting, you should, because, you will be learning better if you do that. And the other thing is, this course is, even though this is the first course for computer science, it's very challenging. And it's not, I mean, we get like only 50% of the students succeeding in this class. That's very low, but that's because the class is challenging. Not everybody can handle it. So here is a suggestion I can give you to determine whether you will be comfortable with this class or not. If you are a person who can comfortably say, I'm very good at math, I love math, then you will be comfortable with this course. It's the math skills, it's not the math knowledge, it's the skill that is required in a math class that is required here too. So that skill is not there in everybody. I mean, we not all of us have that. So unfortunately, that skill is necessary. And so you can ask yourself that question. Am I comfortable in math? Am I a math-loving person? Then you're going to be fine. If you say I'm shaky on math, or I hate math, that kind of person, then you should not be doing this. You will be wasting your time. So that's the only way I can tell you to figure out whether you should be in this class or not. In this major, the entire computer science requires that kind of skill. So this first course and second course, these 2 courses are, it's 271 and 272 are the foundations, and they are both very challenging. And the remaining courses will be challenging if you don't have good knowledge of these 2 courses. The remaining courses will be impossible to handle. So you really have to learn this very well, 271 and 272, to be a computer science major. So I strongly advise you to ask yourself the question I just mentioned and determine whether you should be continuing with computer science major or not. I hate to see too many students failing and dropping out, so that's why I'm warning you at the beginning that only if you or a person who can handle this, then you should stick with this major. Otherwise, rethink about the major. That's my advice. All right, so today I'm going to first explain the website Blackboard course and how it's going to work. And then we'll be going over the material for today's class. I'll be actually teaching today's material. In the future, I will not be teaching physically in class. Instead, you watch the video of me teaching that material at your own time. You don't have to be there in the class. You can watch anytime. So the class meeting is basically for answering your questions and also for additional practice, basically, to give you a better handle on the course. On each class material, you will get better handle after doing some practice problems. The computer science, this course and remaining computer science is all basically like a little more advanced math. You know, the mathematical skill will be necessary to handle everything. All right, so I'm going to share the screen and go to the Blackboard first and show you important things. Apparently, some students never visited the Blackboard. They're sending me questions that are already there on Blackboard. And so please read, go to the website and read everything first before asking questions. I got really tired of answering all the emails. Basically, all the emails they're asking same questions that for which the answers are there on Blackboard, and I have to answer them all. It was a lot of time-consuming work answering their questions. Anyway, I'm sharing my screen, and when I share the screen, when you see my screen, you will see half of the screen with the material. Right now, it's going to be the Blackboard, and the other half will be a whiteboard on which I can write. And when I write, you'll be able to see what I'm writing. So just like a classroom, you'll be able to see what I'm writing on the whiteboard. All right, so let me share the screen. Okay, on the here I have the Blackboard right there, and your course is there. And what you see on the right side is the whiteboard on which I'll be writing. Okay, so on your Blackboard, the read this first is something you need to read first. It explains everything about how the course will be handled, and all those basic information are there. And the course information is essentially syllabus. This video of me introducing myself, you don't have to watch that, but you know, if you want to, it's there for those who want to see my introduction. And then the rest of the course information is all about, you know, how to get your textbook, starting from how to get your textbook to how you'll be graded, and all the information about the course is here, and you have to read it at your own time. And the quiz is, there's a quiz on the course information, basically. If you understood everything in the course information, then you'll be getting a good grade in the quiz. And where is that quiz? The quiz is under the tests and quizzes section. That is a quiz, and by clicking there, you'll be able to take the quiz. But I would advise you to read everything before, course information, and then read this first. You have to read those before taking the quiz. And the quiz is due Monday. Everything is due 5 minutes before the next class. Always, whatever assigned will be due 5 minutes before the next class. The course map basically gives you the full guidance as to what video you should watch and before each class, and what topic it covers, and all that is there. So for video 1, video 1 is the first class material, section 1.1, but I'll be teaching that today. So you don't have to watch the video 1. The video 2 is the one you had to watch before the next class. So for each class, you need to watch the video before the class meeting and bring up your question in the class meeting. I had to stop sharing for a second so that I can take attendance. So let me stop sharing. All right, I'm going to take attendance now. I waited because today's the first class, so I wanted to allow the late attendees. So I'm taking attendance now. Okay. And sharing screen again. All right, so this course map is your guidance. You should follow this, and it tells you what assignment is due when, and the actual, I'll show you where the assignments will be. And whenever the project is due, it's going to tell you when it is due and all those. Actually, this only tells you what are the assignments after each class that you're going to be given. But the assignment will be posted on the submit assignment section. I'm going to show you that in a few minutes. So this is only for information. The course map shows you what problems you had to do just for the information. But you'll be able to see exactly what is due when and when it is due in the submit assignment section. So I'm going to show you that in a few minutes. So you need to consult the course map to figure out which videos you should be watching before each class, and so on. The course calendar, if you go to course calendar, it shows what is due when. See right here, Monday morning, 9:20 a.m., you have 2 things due. It shows right there. By clicking there, you will be able to see what they are, what exactly they are. So the course calendar is useful to see what is due in case you forget, or in case you don't check the submit assignment section. It's there in this section also. So your information is available everywhere. So let me go to the course material. And if you go to the module 1, for example, click at that, then you see the entire chapter 1 stuff right here. Module 1 is essentially chapter 1. All right, 2 people showed up late. Let me take their name down. Hold on. So for example, the PowerPoint lecture, I'm going to use PowerPoint lecture when I teach, and that PowerPoint lecture is right here. If you click at this, you'll be able to download it, right? Just by clicking, you'll download and print if you like, or just open it up and view, whatever you want to do. That for each class, the PowerPoint lecture is right there. And also the video of me teaching the class material using that PowerPoint lecture is what this video is right here. So that video is right there. So this is our lecture 1. The lecture 1 you don't need to watch because I'm going to be teaching that today. Today is the first class, so you may not have watched the video, so that's why I'm going to teach that material. And now before next class, you need to, if you want to read the PowerPoint lecture 2, you can do that by clicking at this. But more important thing is to watch the video. In the video, I will be teaching the material with the same PowerPoint lecture, using that lecture. So therefore, if you watch the video, you don't need to print the PowerPoint lecture. So this is the material you need to, this is the video you need to watch before the Monday class, and bring up any question for discussion. And also I'll be bringing up questions for additional practice. All that will be on this topic. On the topic taught in this lecture video 2 is what we'll be discussing on Monday. And then the third class, which is next Wednesday, you have to watch this video before that class, video 3. So that's how it goes. Um, and that's what the module 1 is. Similarly, module 2, the modules correspond to chapters in your book. So there are 6 chapters we need to complete in this course. The course supplements has additional supplementary material, and when we need it, I'll tell you to go and look up course supplements. It also has the course supplements has reviews for each test, and so when the test time comes, I'll let you know when to do the review. Right here, this is review for test 1. Now, in case you don't have, some of you may not have the textbook yet. For that reason, I have permission from the publisher to place chapter 1 in right here. Chapter 1 is right here, so you can print that and use that. You need the book to do your homework and for additional reading, so the book is necessary. But if you, that's why I send you all a message asking you to order the book. About 2 weeks ago, I sent that message. So anyway, if you don't have the book yet, you have chapter 1, access to the chapter 1. And before we finish chapter 1, you have to have your printed book available. It doesn't have to be printed book, it can be ebook. The ebook is faster to get, as soon as you order it, they will send it to you by email or something. Immediately they can send it to you. So it'll be faster. But only difference between printed book and the ebook is ebook has no value at the end of the semester, but printed book you may be able to sell to other students. That's the only difference. Okay, after you get the book, here is the error corrections, and there are some errors here and there, and also some changes I made after the book was printed. You need to make those changes by following this document, error corrections in the book. So after you get your book, you need to make these corrections on your book, physically make those corrections throughout the book. Only then you will be working with the correct information. And there are other documents when we need them, I will let you know. So right now you need the chapter 1, print that and use it if you don't have your book, and make the error corrections in the book if you already have the book. Now going on to the submit assignment. Submit assignment is where you go to submit your assignments, and I'm going to show you how to do that. So submit assignments. It tells you first that you need to do the, you need to introduce yourself on the discussion board. That's part of the first assignment. And after reading course information section, you need to take the quiz found on the test and quizzes section. And that's what it tells you right here. You have to do all that before August 30th, 9:20 a.m. So that is the first basic assignment. After that, the actual assignment on the material is right here. This is the first assignment on the material. So this assignment, homework 1 right here, is on the Turnitin system. Turnitin system is a assignment system that is not really part of the Blackboard, but Blackboard has access to it, so we can access Turnitin system through Blackboard. So it's a good system that allows you to submit assignments and allows me to write my comments and feedbacks right on your assignment, all electronically. So it's a very convenient system, and I'm going to show you how to work with that. So here's homework 1, and it tells you what problems you have to turn in. Section 1.1, all the questions. Section 1.1 has questions you need to write answers for. It's not problems, it's just questions. And so when you're ready to do the assignment, when you're ready to submit the assignment, you need to click at this link right here, view complete, that's the link. Now, this link will allow you to submit your assignment. Now, before going to that link, let me explain. You can actually handwrite your solutions and then scan it. And so it has to be converted to electronic document. So you can handwrite and either scan it or take a picture with your phone. Those are acceptable. But if you type using any editor, it'll be much better, because any type document will be easier for me to read and grade, and my feedback will be right at the location where I need to write. I can write my feedbacks exactly where I want to write and things like that. But if you handwrite it, my feedback system doesn't work very well. It's kind of, you know, both you and me will be in some disadvantaged situation if it is a handwritten assignment. So you only have to type the answers. Never write the question in your homework assignment. Just type answer for each question, and you have a typed document. It's much easier for you to work with and for me to work with, and also you will see my feedbacks much better. So I'm going to show you how to upload your assignment. So view complete, you click at that. Then you will see this page where single file upload, that's all you can do. You can only upload one file. So everything you need to upload must go into one document. It can have several pages, but it has to be one document. And then you select your need to select your name. There are only two names appearing right now, but after you all start to work, it'll show all the names. So select your name, and then submission title will be homework 1. You can type the title exactly how you want to type. It doesn't matter. You're indicating what assignment it is you're submitting. And then you select choose from this computer. You always have to upload it from somewhere. So you had to have it in your computer first. So if you hand wrote it, then you should have it scanned first. If you have typed it, then the typed document is already there. So choose from this document and then go and find the document. Find the document by navigating your computer. And so if I select that document and open, then it shows the name of the document right here. And if that's not it, you can clear the file and start over. Well, if this is the document you want to upload, you click at upload. Now I don't want to upload anything right now, but you click at upload, it'll upload it. So everything the assignment can only be uploaded to the Turnitin system in this manner. And after uploading it, if you want to make sure it's there, I mean, if the name appears right here and then you click at upload, it should go through without any problem. It will show you the document. During uploading, it will show the document. So you'll be able to see that. And then it'll confirm. At the end, it'll give you a confirmation. So it should be there. But if you want to make sure it's there, just a minute later, if you go to my grade section, you will see the assignment here. The assignment homework one, the homework one assignment, it'll show here on the right across that your document is here. So nothing is uploaded in this is showing my grades, grades, and I don't have anything uploaded there. So if you have it uploaded, it'll show you here. And to view it, to view the assignment, you actually click at that, at this homework one after I grade it. So after you submit, before the following class, at some point, you should view your homework. And there will be my feedbacks and everything. You read all those feedbacks and understand what mistakes you made and learn from those mistakes and bring up any question in the following class and so on. That's how you learn. And if you don't look at your assignment after I grade, then all the wrong understanding you haven't corrected them. You still have the wrong understanding. So going on with that wrong understanding is a bad idea. You should look at your assignment after I grade it. This is one place where this whole system fails compared to the in-class discussions. In class, when I return the quiz or homework to the students, I'm returning to them in class, in person, and they immediately take a look, you know. But when I'm grading online, sometimes they don't take a look after grading. And that is one reason why why some students fail the course. They don't look at the assignments that were graded. And so I had better success when we were having in-class meetings than now. So now my success rate is less than 50%, unfortunately. It's something I cannot change. Mostly the reason is the students are not looking at the graded homework assignment and learning from the mistakes. They just go on with the wrong understanding. And that's one of the problems I cannot change. I cannot solve that problem. Anyway, you can see your assignments and the grades for those assignments right here. If the assignment has not been graded, then you will not see a grade, but it will show you that the assignment is there. It has been turned in. So if it is not there, that means you didn't turn it in. Something went wrong. So you have to go back and make sure to submit that again. So that's how your assignments should be submitted. When it comes to tests, right now you have a quiz in the test and quiz section. Later, you'll be taking tests in the same section. The discussion board is there for you to have discussions. So anytime you want to, you have a question that you want to post to others, you can post it right there. Let me go back to that. Something went wrong with the Blackboard. I'm trying to fix. All right, there we go. Discussion board. Right now, I have posted a forum to ask you to introduce yourself. This is to make you get started with this. That's why I'm asking you to post an introduction of yourself in this section. This way, you know how to work with this, and also everybody can introduce each other. The idea of this discussion board is to create your own discussions by creating a forum. You create a new forum and post a question that others can answer. And I can also answer. So whoever sees that first will answer your question. And it is a useful way to communicate with everybody in class. But students are not using it very often, and I don't know why, but I advise you to use it whenever you have something to discuss with the others, or you have a question that you want others to answer. And then I already explained my grades. Your grades will be showing in that section. For each assignment, each quiz, everything you did, the grades will be showing. And later on, I'll be also adding items like course grade and assignment average and things like that. So you'll be able to see all the numbers there. All right, any question on the Blackboard? I think I explained everything.
Professor, I have a question. In course calendar, there's 2 quizzes that are due, one for course information and then one that says quiz 1. Are those both the same quiz or are they separate?
Oh, okay, let me see.
In course calendar.
Course calendar. Okay, there's only one quiz in the quiz section. Let's go to course calendar. That's quiz 1. And close that. Let me look at the other one. Quiz and course information.
So are they the same thing?
The same thing, actually. I had a different name for that assignment before, and somehow it kept both. So what all you have to do is just go to the test and quizzes and take this quiz. That's the name. I'll find a way to delete the other one. Okay, that's all you need to do. Just one quiz. But this is the only quiz you need. But the Turnitin assignment is due. But that it should show up in the. See, you have the submit assignment. If you go to submit assignments, you'll be able to see what assignment you need to submit on the Turnitin system. And right here, there's homework 1, and that's not showing on the course calendar for some reason. So I'll check on that. But you have 2 things. One is quiz, and this assignment has to be submitted before Monday. And also you need to do the introduction of yourself on the discussion board, introducing yourself by clicking at the discussion board. Yeah, right here. So those 3 things have to be done before 9:20 a.m. Monday. All right, so you have plenty of time, but 3 things to do. Don't forget. There's only one quiz. It has the course calendar shows 2 quizzes. By mistake, there's only one quiz. Any other question? Okay, very good. So that means I can now move on to the actual material. Let me trim that. So this is the PowerPoint presentation that I'll be using today. And this is posted. I showed you where it is posted. It's posted on the Blackboard if you want to review it. But the video, the lecture videos are going to show you the same thing, this PowerPoint presentation with my explanation. that's what the lecture videos will be. So therefore, you don't really need to separately print the PowerPoint presentation. Anyway, let me begin today's material. Introduction to computers and computer programming. That's what this course is about. It's called introduction, but it is a lot more than that. I don't know why they decided to call it that. Anyway, in this first chapter, we'll be learning the basic architecture of a computer. Nothing hard, just the basic things. And then we will be also understanding what a computer program is and programming languages and what is the language of the computer and stuff like that. All that will be in this section. We will be also, so let's understand the computer concepts. A computer, basically, a computer is a machine that can accept and manipulate instructions from us. That's what makes the computer different from other machines. In the other machines, you can only push a button to turn on and push a button to operate, and that's about it. But here, we can write instruction to have this machine follow those instructions and manipulate things. So if I ask you for a definition of the computer, you can say computer is a machine that can accept and store and manipulate data accurately and extremely quickly. That's basically what would be the definition. It can carry out instructions and it can carry them out very quickly at a very fast speed. Those are the important features of a computer. People who don't really know much about the computer think that they are intelligent machines, but there is no intelligence in any machine. The intelligence that appears in a computer is the intelligence of the programmer. The programmer who wrote the instructions for the machine to do those things. That's what the machine is doing, whatever the programmer instructed. So the intelligence that you see is the intelligence of the programmer. The programmer really has to be intelligent to be able to write these programs. And to bring up some intelligence in the machine, the programmer has to be smart. So the very smart programmers get hired to excellent jobs and they get paid excellent. One of my students, well, he had, for a while, I had communication with him, and he was hired at Microsoft, and he was making $400,000 a year. So that's just one example of what some real good programmers get. You get very rewarded job, not only financially rewarding, but also, satisfactory job, you can get. But only if you are really good at it, you do very well. Anyway, it's the programmer who's intelligent that shows in the machine. The machine itself has no brain. There is no brain in this machine, no intelligence at all. So it doesn't think. It cannot think. It cannot figure out anything. And that's why the programmer's job is difficult, because since this machine doesn't think or figure out anything, you have to be very clear, absolutely clear with your instructions, with nothing for the machine to figure out, for the machine to try and understand. See, when we communicate, even if we make a mistake in the statement we make, the other person can still figure out what I'm trying to say. That's because the people have brain and they can figure out. The machine doesn't. And so you cannot leave anything for the machine to figure out. You have to do everything accurately, with everything perfectly accurately. No mistake can be there. That's why it's not so easy. So let's understand the definition of a computer. A computer is a machine that is capable of accepting, storing, and acting on data and a series of instructions given by the user at a great speed and high degree of accuracy. So speed and accuracy are the two important features of a computer that we take advantage of. It does things very fast and it does them accurately, and it never makes a mistake. It cannot make a mistake because it is only following the instruction, and only if the instruction is wrong, it can go wrong. And instructions are the programs written by the programmer, and once you verify the program is right, then computer cannot make a mistake. It has to follow those instructions and end up with the right results. So so if I ask you for the definition of a computer, your statement has to have these some of the keywords here. You can make up your own sentence, but the main important fact about the computer is it is capable of accepting instructions and data and carry them out at high speed and very accurately. Those are the key things that must be there in your definition. Now, solving a problem using a computer means you have to write the program. See, the program is the set of instructions that tell the system how to carry out the task. That's basically what the program is. So to solve a problem using the computer, you have to know, the person who is writing the program has to know how to solve it. And he has to do more. You have to break up the process into very simple instructions, very basic instructions, and write them in an order so that the computer can follow them in that order and end up with the results. The computer has to follow those instructions you write in the order, and it should end up with the results without having to think or figure out anything. That's why the programmer has to do a lot of hard work to make this program that is acceptable. It's if you're solving let's say you're trying to solve a quadratic equation. To write a program for that, you need to be able to know how to. You should know how to solve it, and also you have to figure out how to break up the steps, the solution process, into very elementary steps. So it's much harder to write that program than solving the quadratic equation. You can solve the quadratic equation in 2 minutes, but it'll take several hours to figure out the computer program to solve it. So why do we then write the computer program? Why not solve it ourselves? Anybody can answer that? Why do we bother to write computer program to solve a quadratic equation instead of solving the quadratic equation ourselves when it's, it's easier to solve ourselves than writing computer program? Can anybody answer that?
Will the program just be more efficient in order to save time?
Program will be more
It will be more efficient in saving time.
more efficient. Well, actually, if I'm trying to solve a quadratic equation, and then I can solve it faster by hand than writing a program. So why would people write program? It's not more efficient if I'm solving just one quadratic equation. I can solve it faster than writing program. So it's not quite right to say it's more efficient. I can solve the problem faster than writing program. But we still prefer writing program for some other reason. And what is that? Okay, I'll go ahead.
The computer itself can accurately tell you the answer.
Well, I can solve it accurately too. It's not just accuracy. There's something more than that. Yeah, let me explain. Once you write the computer program to solve the quadratic equation, you can use that program to solve any quadratic equation for anybody. So it's now useful for the entire world to solve all their quadratic equations. Understand? That's why the program is valuable. Once the program is written, anybody can use that program to solve the quadratic equation they have. And it will be, yes, it will be doing correctly, accurately, and fast. But if I'm solving just one problem, it'll be a lot easier to solve that by hand than writing program. But I'm writing program because it's now useful for everybody in the world to solve quadratic equation. That's why it's useful for the whole world. That's why we write computer programs. So let's understand the definition of computer program. A computer program is a set of instructions written for the computer to guide it through the process of achieving a specific task. That's what a computer program is. So to achieve a specific task, you're writing step-by-step guidance that will guide the computer through the task, and it'll end up with the results. You know, a computer is not thinking or figuring out anything. It's following your instruction to get the results. That's what a computer program. So in your homework, in your test, questions like this will appear. What is a computer? What is a computer program? You have to have the keywords in your answer. When I already explained, if you're writing definition of computer, what keywords should be there. If you're writing definition of a computer program, the keyword is instructions. The computer program is a set of instructions that is going to guide the computer through the process of achieving a task. So that keyword is instructions. I have seen students writing answer like this. A computer program is a program that tells the computer what to do. Well, when you say program is a program, that's not the right way. That's the wrong answer. Okay, you have to have the right keyword. Instructions is the right keyword. And it's not telling the computer what to do. That's not the right way to put it. It's guiding the computer through a certain process to achieve a task. So those keywords have to be there. When the program is a professional program, marketed in the market, that's called software. So software is same as program that is professionally marketed. Hardware would be the computer itself. The computer and the associated devices would be the hardware. Like computer needs a keyboard and a monitor and all those hardware. Those are all called the hardware. I already asked that question and explained. The reason for writing programs is because once you write them, it's good for everybody for the rest of the life. Everybody can use for the rest of the life. So that's why it's valuable. But writing a program is harder than solving the problem yourself, but it becomes useful for everybody all the time. That's why we write it. Why do we prefer to use a computer with a program to achieve our tasks? One of the reasons is it's always accurate and it is extremely fast. And so, for example, if you go to these offices, they use computers to achieve everything. For example, look at the phone company. They prepare the phone bills all automatically now. The computer prepares them, and no humans has to interfere with that. And I mean, if you go back like 30, 40 years, 40 years back, all bills were prepared by humans. And well, you were not around then, but I was. And I can tell you it was a horrible experience with the humans preparing your bill. So many mistakes, and you have to call and yell at them and fight with them to get the right numbers. And it's miserable. But after the companies started using computers to prepare the bills, it's always perfectly accurate. You know, you don't call your cell phone company and argue with them anymore, right? So because they're all prepared by the computers and there are no mistakes. And also these bills are always prepared on time, and because there are no humans involved, all automatically done by computers. And these computers keep making the bills and they never get tired. They never ask for a coffee and never ask for, you know, sick leave or anything like that. So, you know, it's an amazing worker. And that's why people use the computer now instead of people, you know. But to be able to use the computer, you need programmers to program it. So that's where the programmers come in. But anyway, the reason for using computers is it's always accurate and very fast and works forever without asking for anything. uh, so let's move on. A computer system would have several components. The computer itself is usually a box with key components. And then externally, you need other things to work with the computer that are keyboard and monitor and things like that. So all the components that you need to work with the computer are these. So the computer system, what we call computer system, would normally have all these. Input device is the device that allows you to communicate with the computer. So keyboard, diskette is no longer used, but you know it is a input device. CD, mouse, scanner, these are all input devices. Output device is a device that allows the computer to give us the feedback, give us the information back, the results. So that'll be monitor and printer. Basically, those are the commonly used output devices. What we call central processing unit is the computer itself. That is the computer. So inside that box, the main component you have is central processing unit. And there are other things like memory and stuff inside the box. But the main component inside the box is central processing unit. So these are considered to be the components of the computer system. So you can see in this picture, inside the box, you have the processor or central processing unit. That processor has within it an arithmetic logic unit and a control unit. The arithmetic logic unit is where the logic is handled. The control unit is for controlling overall operation, everything that the whole system is managing. It manages the whole operation of running a program. That's what the control unit is. So those two are part of the processor. The main memory, or also called random access memory, is outside the processor, but inside the box that you buy. Because the memory has to be part of the computer. And I'm going to explain in a few minutes what memory is for, but these are the components. So these are usually found inside the box that you buy as the computer. Now let's understand the memory. The memory is for the computer to use as a workspace, basically. We don't have access. The users don't have access to the memory inside the computer. Now you have heard people saying, I need to upgrade my memory. They're referring to the memory inside the computer. That memory is different from hard disk or your disk CD or external disks, external hard disk, and all those are different things. Memory is similar to memory in our brain. So let me use a simple example. Suppose that I write two numbers on the board. So let's go to the board, and I'm going to write two numbers, okay? 15 and 9. And so you can see the numbers now. And I ask you to add these numbers in your head. If I ask you to add these numbers in your head, can you tell me the process of you adding these numbers in your head in a step-by-step manner? You have to break it down to steps. What you are doing first and what is second thing in your brain, the brain is doing. What is the next thing? You have to give me step by step. This is how you break up a programming task into a program. You break up the task and write down the steps exactly in this by thinking about these details. If I'm adding 15 and 9 in my head, what are the steps? Can somebody tell me the first step? The first step, let me tell you the first step. You're reading the two numbers first. That means you're putting the two numbers in your memory. Now they are in your memory. Can anybody tell me the second step?
You said we're adding the two numbers, right?
Right.
So
So-
now you have to program the computer and tell it to do operation of addition.
Yes, that's what I'm asking. You know, you have to break it up into steps, and then these steps will become individual statements in the program. So the first step is, if I'm adding these numbers, I'm asking you to add these two numbers in your head. Then what is the first step? First step is reading the two numbers, right? When you read, you're actually taking it into your memory. And the next step is adding. Go ahead.
You take the 15, and I'd assume you just you tell the computer to add it by integers of 1 until
Right.
it gets to 9.
Exactly. Next step is to add the two numbers. Right now we are talking about we're not talking about computer. We're talking about our brain, adding
Okay.
numbers in our brain. So when I am adding two numbers in my brain, what are the steps? First, I'm reading it. When I read it, I'm taking it into my memory. And then inside the memory, I'm adding them and putting the answer in another part of the memory, right? In my memory now has the answer when I do this. So that's 24. 24 is in my memory now. So that's the second step. I have added them in my head, means I have added the two memory numbers, 15 and 9, and put the answer in another part of the memory. Now the 24 is there in my memory. What is the next step? The next step is I have to either say the answer 24 to you, or I have to write the answer 24 on the board so that you can see. That's output. Okay, either I say the answer or write the answer. So there are three steps. First step is reading 15 and 9 into my head. That is input. I'm taking the input and storing it in my memory. Next step is adding the two in my memory and putting the answer in another memory. Third step is saying the value of the third memory or writing the value of the third memory. That's exactly how you break up a computer program, exactly the way our brain works. So the computer was designed to mimic our brain, but they're not close to our brain yet, but it does some of the things our brain does. So that's what the memory of the computer is there to work like the memory in our head, okay? So in order to add two numbers, the computer has to have them stored in memory. And then what is in the memory can be added by the computer. The computer can only work with the memory inside the machine. And it will add the numbers, put it in another memory, and then it will tell you what is in that other memory. That's how the program works. So a program works exactly the same way our brain works. And the processor in our brain is similar to the processor in the computer. And the memory in our brain is similar to the memory in the computer. So the memory in the computer is for the processors to use, not for us to use. We have no access to it. The programmer, when the programmer writes instructions, he or she will be writing instructions telling the machine to do something to memory. So that's what the memory is for. It's more like the workspace for the computer. Now, auxiliary memory or secondary storage, what we call secondary storage is what the hard disk is, or disk, CD, those are secondary storages. What are they for? They're for permanently storing things. So anything you do in the computer, whatever the result is, if you want to permanently store it somewhere, you need a hard disk. When you're typing something in the computer, what you're typing is going into the memory. And what you see on the screen is what is in the memory. And when you turn the computer off, the memory is turned off. Memory has nothing after that. So that's why you have to put it in a permanent storage before, if you want to keep it, before turning off the computer. So the memory of the computer is for the computer to use, and it is only available and working while the computer has power. It needs power to hold things. And as we proceed, you will understand better why it needs power to hold information. All right, so let's go on to working with, so memory of the computer basically is for the computer to use, and it is inside the box. And upgrading a memory, they're really little chips that are plugged into the motherboard of the computer. And upgrading the memory means plugging in more chips to enlarge the memory. Now, why do people upgrade the memory? Why exactly do you need more memory? Well, the computer is using memory for everything. For example, when you are running a program, the program has to be copied into the memory first, and then computer will go by the instructions. The program is a bunch of instructions, and it can go by them only after it has them in the memory. When the program is on a hard disk or something, it cannot read off of that. It has to go into the memory first, and then it'll carry out the instructions. And if you're typing data, they're all going into the memory. And only when you want to save them, you click the save command. That's when you're saving it on a hard disk or somewhere permanently. But until then, it is in the memory. So the memory is used for everything. The program has to go into the memory. The data you type has to go into the memory. And if you are using several programs at the same time, you have all of them copied into the memory. So you need a lot of memory. And if you don't have enough memory, what you will see is if you're running more than one program, things begin to slow down. They're not working as fast as you expect. And why is that? Because when the workspace is small, when there is not enough workspace available, the computer has to spend time searching for space in the memory, and that slows it down. So if there is plenty of workspace available, you will be working faster. You can imagine yourself, if you have plenty of desk space, then you don't have to search for space. You'll be doing faster. But if you have very small space to work with, then you have to find space. And so you're spending time finding space to put things on the desk, and that makes you slow. So things will be slowing down if there is not enough memory. So if you upgrade the memory, computers will work faster. So that's why memory is upgraded. The memory is the workspace for the computer. All right, when you're working with the computer, what are you doing? You're providing input, and the input will be data and program. So if I'm using a program to manipulate some data, then I have to provide the program to the computer and the data to the computer. They all go into the memory. I'm saying they go into the computer, but they go into the memory. And then the program will be used to manipulate the data, and the result will be the output. So data and program will go into the computer and output come out. Now let's understand the operating system. Now I said earlier, computer can only work with programs, and if there is no program, the computer cannot do anything. So if there is no program in your computer, and then you turn the computer on, you will only see a black screen with a blinking cursor. That's about it, if there is nothing, no program available. But instead, when you turn the program on, you see some icons and menus and all those things coming up. You can see my screen with the icons at the bottom and all these different menu items. So there must be a program that's doing all that, right? Yes, without a program, the computer cannot do anything. So in order to make the computer work with the user, work with you, and communicate with you, they have to provide the instructions to the computer that will let the computer know what to do as a result of each of your actions, like moving the mouse. When you move the mouse, the arrow on the screen has to be moved. And when you click somewhere, it has to do whatever that meant. So all those instructions have been put together into one big program, and that program has to be there in the computer for the computer to work like a computer. Otherwise, it would be a just black screen with nothing. So this program that makes the computer work like a computer and makes you interact with the user is called the operating system. So the computer needs operating system to be able to work like a computer and to be able to work with the user and to do things as a result of you clicking somewhere, and all that is put together in the operating system program. So this program has to be there before the computer can work with you, and therefore every computer you buy in the market comes with the software installed on the hard disk. It's only on the hard disk, not in the memory. Memory is temporary. It's only available when the power is on. So therefore, this operating system program is there on the hard disk. And when you, nowadays, it's always there on the hard disk. Now, if you go back a few years, 20 years, the hard disk wasn't there. So we had to use an external diskette to have the operating system. And every time we turn it on, we had to insert that disk first. And that disk is called the system disk or startup disk. So you had to have that to be able to have the computer work for you. So anyway, as soon as you insert the system disk, but nowadays, as soon as you turn the computer on, the first thing the computer does is it copies the operating system from the hard disk or the system disk you inserted into the memory. See, the program has to go into the memory before you can use it. So that's why when you turn the computer on, it takes a few minutes, some kind of noise is coming out and all that. What's going on is it's copying the operating system into the memory. Only after that, when the operating system is in the memory, it can now bring up these icons and menus and all that on the screen as a result of the instructions in the operating system. And after that, the mouse will be functioning, all that is because of the operating system. So when you turn the computer on, what is the first thing the system has to do? It has to copy the operating system into the memory. And then only after that, it will be ready to work with you. Moving on, oops. So what is the definition of operating system? It's right there. Operating system is a program that controls the overall operation of the computer. To extend that, I would say, and allows interaction with the user. All that is part of the operating system. So I already explained it would be either in a system disk or startup disk or in the hard disk. Now, modern days, it's always in the hard disk because all the computers nowadays have hard disk. Okay, it's the operating system that makes the computer look and work the way it works with you. And if you take a different computer from a different manufacturer, like Mac, as opposed to Windows, the Mac works differently, slightly differently, because the operating system is slightly different. So the popular operating systems are Windows for the normal for the most computers, and Mac uses its own operating system called Mac OS, Mac operating system. But the other computers are using Windows. These are the two major operating systems that are used right now. So Windows computer and Mac computer look and work slightly differently. But if you go back, the whole idea of using this kind of operating system it came from Apple. Before Apple came up with this operating system, the operating system that was in use with the IBM computers was DOS, DOS. And, you know, I mean, you being the new generation, you never had to work with that. But that DOS operating system means when you turn the computer on, it will be a black screen with the cursor blinking, and there is now no icon, menu, none of that. You have to type a command telling the system, if you want to tell the system to open a certain file, there's a certain command you have to type. After opening the file, to do anything with that file, you had to type another command. So you had to know all those commands. There are hundreds of commands that you need to know, and you have to be able to use it at the right order at the right time. And that was a pain. So everybody has to learn DOS system commands to be able to use computer. So computer users were very rare, and they were in demand because not many people can use computer at that time. It was much later, the Apple company was also using an operating system like the DOS at the time. And then they came up with this better operating system, which produces menus and icons and
Professor, time.
I'm sorry?
It's time.
Yes, I'm almost finished. So the Apple introduced this operating system, and after that, Windows is a copy of the idea of Apple Mac system. They basically copied the idea. And anyway, now we are using computers comfortably because of these operating systems. All right, so that's all the material we needed to learn today.
Professor.
Yeah.
My name is Benjamin Chen. I'm on like a Zoom call with like another student because my phone isn't working right now.
Yeah.
So I don't want you to mark me absent just in case. So I'm letting you know. I'm just like I'm still like watching your Zoom.
Okay.
Through someone's phone. We're in a class together.
What's your name again?
My Benjamin Chen.
Benjamin Chen. Okay.
Thank you.
Yeah, no problem. All right. So yep, we're done. You need to do those assignments. 3 things to do, remember, before the Monday class. And enjoy the rest of the day. I will see you on Monday at the same time.
See you Monday.
You have to watch the video before the class. Remember that. And
No problem.
Questions.
Thank you.
Okay. Have a nice day, everybody.
Have a good day, Professor.
Have a good day, Professor.
You too. Thanks. Bye.
Have a good day, Professor.
Yep. You too.